Organic chemistry deals with millions of different molecules, and memorizing each one individually would be impossible. Functional groups are the reason this subject is manageable. They let chemists recognize patterns and predict behavior instead of starting from scratch every time. A functional group is a specific, recurring group of atoms within an organic molecule that largely controls how that molecule behaves. If two molecules contain the same functional group, they tend to have similar chemical reactions and similar physical properties, even if the rest of the molecule looks very different. Chemists often represent the rest of the molecule with the letter R. When you see something like ROH, that means any molecule with an OH group attached. Whether R is small or large, straight or branched, the OH group gives alcohols their characteristic behavior. This works because functional groups create distinctive electron patterns. Differences in electronegativity make bonds polar. Lone pairs allow atoms to donate or accept electrons. Double bonds and resonance spread electrons out. All of that determines where reactions happen. In a sense, functional groups have chemical personalities, and those personalities come from how electrons are arranged. It helps to separate a molecule into two parts. The carbon skeleton is the framework of carbon atoms that sets the size and shape. The functional group sits on that framework and controls most of the reactivity. Two alcohols may have very different skeletons, but they still undergo similar reactions because they share the same OH group. Some common functional groups show up again and again. Alcohols contain OH and can hydrogen bond. Carbonyl groups, like those in aldehydes and ketones, contain a CO bond with a strongly electrophilic carbon. Carboxylic acids have COOH and are acidic. Amines contain nitrogen with a lone pair and are usually basic. Alkenes contain CC bonds that undergo addition reactions. Alkyl halides contain carbon-halogen bonds that readily participate in substitution and elimination reactions. Functional groups also control physical properties. Groups that can hydrogen bond, like alcohols and carboxylic acids, tend to have higher boiling points. Polar functional groups increase solubility in water, while large hydrocarbon portions make molecules more hydrophobic. This is where the rule like dissolves like comes from. Most organic reactions are best understood as functional group transformations. An alkene becomes an alcohol. An alcohol becomes a carbonyl compound. A carboxylic acid reacts with an alcohol to form an ester. Learning these patterns is far more powerful than memorizing individual molecules. Many real molecules contain more than one functional group, and their behavior reflects the interaction between them. Still, the same core idea holds. Identify the functional groups and you understand the chemistry. In short, functional groups are specific atom patterns that create predictable electron distributions. They define how organic molecules react, how they interact, and why organic chemistry follows patterns instead of chaos.